Good afternoon, guys, and welcome to the Industry IoT Virtual Workshop Series. This afternoon, we are lucky enough to be joined by Graham Herries, who is the Digital Technology Director from Laing. Welcome, Graham.
Good afternoon, everyone.
We will begin with the initial presentation. Graham will have his PowerPoint deck up on the screen that you should all be able to see. There is a Q&A chat room. For most of you that have joined these sessions previously, you know how it works. Please post questions in the Q&A chat room, and I will do my best to prompt Graham to answer those questions the best he can along the way. We will allocate a short period of time at the end of the session for some Q&A if anyone has any questions after the presentation, but you're more than welcome to post them as we go. Graham, over to you.
Okay, so Daniel's briefly introduced me there. My background is software and systems engineering. I find myself in construction for the last 5.5 years, having come from aerospace and prior to that defense. So I come with a very different viewpoint to technology and construction to many people who it's a very insular sector is construction, where people tend to grow and either join as graduates or apprentices and then work their way through. So I come in with a very different vision of how life is outside of construction. My PhD is actually in data analytics and machine learning, so I'm reasonably trendy at the moment, and trying to do my best to see how we can best apply that to the sector. Laing, and I always struggle a little bit with how we move this on. There we go. Laing O'Rourke, if you don't know us, we're a tier 1 contractor in the UK, Middle East and Australia. We are an engineering enterprise that continuously strives to deliver certainty to our clients. And I'll talk a bit more about that, and then that explains why we've gone on the particular journey we have. We build a series of great projects, some of which you'll undoubtedly know, but not solely London focused, although the 3 on the right clearly are. Francis Crick, very close to my heart. I spent the last 10 months of that project's life delivering it because it had major systems integration challenges. So there are some other benefits to being a techie every so often, but obviously we deliver up and down the country. And if I look at what we're delivering today, we're delivering everything from a cancer hospital in Wales, brand new hospital in Brighton, and we're delivering the Edinburgh St James retail and an accommodation scheme in Edinburgh. So length and breadth of the country, really. As a sector, where and it's easy for me to say this, having worked in other sectors, we are extremely behind. Productivity is extremely low. We use a lot of natural resources. Cost is very expensive. We're very slow to deliver using traditional on-site construction methodologies. So back in 2013, the government came up with a Construction 2025 report, which strived to achieve those figures you see on the right. Not easy to achieve. We're over halfway through that, and the reality is if you were to look across the whole sector, I think there's very limited improvement in those statistics, other than perhaps lower emissions. There's been a lot done on sustainability in our sector in particular. We've got a slightly different angle to this because we have been working towards this as an individual business, and I'll cover that in a second. If you look at it, because of course one way of getting yourself out of these kind of problems is R&D investment, be it in product, be it in processes, be it in tools and methods. Construction spends 0.5% of sales on R&D, which is woefully pathetic, to be quite frank. We struggle as a sector, and to put that in context, that 0.5% is fundamentally because typically margins in our sector are of the order of 2 to 3% at risk. which is why if you looked at the figures for the last whole year across the tier ones in the UK, we collectively made a loss of 0.5%. So investing in R&D is very difficult for us, but we do what we can. And one of the ways we have done what we can is to adopt an approach which is called design for manufacture and assembly. So basically off-site construction, construction manufacturing, if you want to call it. So taking, disassembling what would traditionally be done on site and bringing it into a factory environment where we can produce it and manufacture it at higher productivity levels, transport it to site, and then it's an assembly task with significant gains on reduction in labour on site, speed of delivery, and significant reduction in waste and energy and improved quality. To deliver this DFMA approach, we built a factory back in 2009, right at the bottom of the recession. Our chairman saw a way forward that when we came out of recession, skills would be in a shortage, and there would be a big boom, and costs would go up, and that really the existing model of on-site construction wasn't sustainable. So we built a factory which delivers the kind of products you see along the bottom there. These are often very large items, you know, several tons. For instance, the beam you see in the middle is a bridge beam, upwards of 100 ton easily, that we put on the back of a low loader, deliver to a site and then install. I'll cover that a bit more in a minute. So to create this DFMA approach, people often think that, you know, oh, modular, it's ugly, you know, there's no architectural benefit. This is a project we've actually finished now in Southwark, in just south of the Thames in London. You can see if you look towards the top of the image, you can see the facade being installed as a complete unit as the building's been moving up. We've been able to deliver a floor every 6 days on this project using our DFMA approach. You know, and if we take that back to the basic components, you can see we're assembling components together, and then we're still using raw material on site. We're using some concrete, but then we've got reduced waste because we've got temporary works from the actual objects that we've delivered, and we then just give things their structural integrity with added concrete. We're able to then produce the facades in our factory. So classically what would happen is somebody would be installing glazing at level 40 on the outside or inside of a building, with high risk, working at height, you know, weather, all those kinds of problems causing issues. However, you know, we're manufacturing the facade in our factory. You know, this is on the floor, somebody installing glazing in a nice environment at head height level, safer, easier, better quality finish, easier to inspect and verify. But of course, when we've got all these components, it means we need to do more design, more digital design, more CAD, and this is where this digital mock-up to reality. So this is really starting to bring in this concept of digital twin to our sector. You know, starting on the left with the concept design, moving through detailed design so that we can then manufacture, how we bring those items together to assemble them, sequencing with the cranes, logistics, people, and then of course recording the as-built information and then using that for the operation. This is this whole term BIM that we have in our sector, building information modeling, and really we've kind of abused it with by starting to term it a digital twin. And what we need to move to from the BIM model to achieve a digital twin is a real simulation of the performance of the building and how that reacts. It's not just as simple as capturing data. If you're not able to tweak any parameters, in my view, it's not a true digital twin. So we mentioned we've got all these components, we're having to design them in a BIM model, a digital twin. You then have simple problems where traditionally most of our staff are used to pouring concrete where they need to pour concrete on any given day. However, we've now got a slightly different life cycle where we've got to design a component, it's got to be approved, it's got to be signed off, it then goes into manufacture, we then QA it, we then put it on the back of a lorry, we deliver it to a staging post, and then eventually it gets delivered to site. So tracking the status of every single component, as you can see in this image, there's some blue in the center of the image, which is a set of components which are due to be delivered today. So everybody knows where they're working. They can see by the color coding that it's been manufactured and it's available for delivery. It stopped a lot of problems. We had a lot of problems at the beginning where we just got things out of sequence and we just missed some of the simple kind of supply chain and logistics. So we developed a bunch of tools and integrated some data sources to make that a lot easier. Nothing rocket science, but the simple things and the visual things have really helped us as an organization. If I then kind of talk a bit, so we've talked about built environment and DFMA. If I give you an example of a bridge, so this is a bridge on the A453, which was a dual carriageway expansion on the way into Nottingham. You know, you can see the level of detail in the model. We began to install abutment shells on day one, and by day 4 we were installing the bridge beams, and day 5 we then cast the deck. Building a bridge of this quality and structure in 5 days was unheard of 2.5 years ago, when we installed it at the side of a live railway as well, which is always a challenging environment. Typically, this would take 6 weeks on site, 6 weeks plus, with a high likelihood of suspension of the line at the side. But you know, this gives us a massive gain in terms of our product capability to the market. And if you think about the number of bridges that are required on HS2, upwards of 1,000, then you can start to see the time gain and productivity gain from building bridges off site and then simply bringing them together as an assembly task. We've been doing a lot of work for past 4 years or so around VR and AR. We've done a lot of work in-house as well as with some small startup partners. For me, it's really about using the technology for where it has a best fit rather than just using it for the sake of it. So, you know, VR-wise, we do a lot with architects, clients, and consultants, really, to walk through buildings, get people to have a feel, because a 2D drawing is not always a good indicator of scale. It helps us with evacuation routes and maintenance routes and all these kind of things, allowing people to walk through the environment. More on the right-hand side is our augmented reality work we've been doing. So we've been using this a lot for client engagement on site. So this is a site, somebody's holding up a tablet, and then they're able to see some augmented overlays. We found it's been really useful for inductions, so site inductions. So what are the activities that are going on today? In this area, we've got these particular cranes, or we've got some hazardous working or some hot working. So again, it's really that ability to put things in context rather than scribbling things on a diagram and without any kind of human context that we would normally understand. So you know, we're finding real use for VR and AR. Limited use cases, as I say. It's always about focusing on the investment. When you're making a tiny profit, you need to use the technology where it drives productivity, and we're finding those examples. Here's an interesting little video. So one of our students was doing a master's degree at Cambridge in construction management, and he put together a demonstrator using HoloLens for how we could do rebar. Rebar's the kind of steel reinforcement that we use in all concrete. And one of the advantages is you can see it's highlighting that there's some bars that are out of placement, and it allows us to, you know, start to think about how we can use these new AR tools with a digital model for comparing data and really visualizing that to our staff on site. Again, it's more of a proof of concept. It's more a problem with the devices and people's use of the devices actually than the technology per se, or a lack of use case. You know, a HoloLens at the moment is typically lasting 2 to 3 hours. And then we've got all the challenges that we have around data and offline data in a construction environment, especially if you're underground. And this is where things like 5G could be a real benefit in the coming year or so. Another thing we've done is produce what we call a toolbox spotter. It's in essence a little camera with a bunch of AI for automatically identifying potential hazards between humans and machines. You know, people walking towards machines that are in operation and vice versa. So that you know, it's very easy to distinguish between a person with high visibility, you know, a hat, helmet, high vis vest on, and a machine. In one of the trials we did, where we had a very near miss, which was avoided by this equipment, and you know, the likelihood of serious injury having occurred, even with all the rigorous safety procedures we have in place for interaction between humans and people operating diggers, somebody completely ignored the rules and tried to cut across somewhere, and the toolbox spotter spotted them and sounded an alarm. So, you know, the potential for these kinds of technologies on site for really helping safety and productivity is huge. The key thing we've got to do is the human aspect so that people don't start to assume that a machine's looking after me, and it's no longer, I don't need to be careful anymore. Really, it's the 0.0001% opportunity that you're trying to catch with this, rather than taking control away from humans. We've trialed tunnel surveying with drones on Crossrail. Interesting challenge. If anybody's ever used a drone, they rely on GPS to fly in a straight line. You don't have any GPS in a tunnel that's 30 meters underground. So, you know, it forces an operator to completely drive it manually and override. You know, there's no automatic course correction. All these things are somewhat problematic if you want to start doing automated surveying, and they're challenges that we need to resolve if we want to use some of this technology, which clearly could have a massive benefit for us. Crossrail tunnel linings is another interesting one. So of course Crossrail's not yet open, so we've not seen any of this, but I can assure you the tunnels are all there and the stations are all there and installed. This is a product set we developed. We have a sub business called GRC, glass reinforced concrete. The aim being to produce the kind of structural tusks you can see on the left, which are double curved, and then the actual station lining surfaces that you see in the middle and the right image. Being double curved, that requires very complex molds to be machined and manufactured, costing tens of thousands of pounds each for a mold to be able to then spray this glass reinforced concrete. This product has been blast tested and everything, so it's quite a high-end product, but it's not heavyweight concrete. It's lighter weight. So we had a problem. You know, I've mentioned multiple tens of thousands of pounds per mold. So we'd been working on some additive manufacturing in one of our research groups in Australia around printing 3D printing wax, and then machining that wax to deliver a mold, which is this concept here, meter by a meter. For the Crossrail stations, we decided to upscale that 3D printing facility to 6 meters by 30, which is what you see here. We've got a huge machine for printing the molds that we then spray the glass reinforced concrete in. And there's actually 2 print heads, so it's not to do a whole 30 meter by 6 meter panel. It's kind of split into 2. That's the aim. You know, that's really then starting to open the mind about what you can do with concrete, because you've got a mold to spray it on. You know, there are lots of simple examples of 3D printing concrete direct. They're very simple for a reason at the moment. We need some advances in materials, and we've taken it from a different angle, which is to work on the mold side of things, and then spray the concrete from the mold. So again, lots of technology. We're very open-minded to technology development. Of course, you know, we can't do it all on our own. We've got quite a collaborative approach, and we use the kind of typical technology readiness levels, manufacturing readiness levels. So we do a lot of work with university in the kind of level 1 to 3 scale, but of course that tends to be looking a bit further out. And then we've actually done quite a few projects with the Advanced Manufacturing Research Centre, which is part of the High Value Manufacturing Catapult. And that's been really successful, taking technology that you know is in that kind of 4 to 6 valley of death area, and then maturing that. So if I give you a flavour of some of that, so we'd already talked a little bit about augmented reality. We've been doing a little more on wearables. So this is around you know, what would it take to be able to speed up commissioning of control panels in a safe manner using augmented reality? And that's been really interesting, integrating Bluetooth electrical testers with the model, with the commissioning instructions, and presenting a set of sequences to an operator. We've been doing some work on facade development for modular housing with robotics. So we're currently about to launch a new factory where we'll be doing a pilot scheme. So this isn't going into production in the next 18 months, but we've been working with AMRC around producing the facade, and we need to place about 70 bricks or brick slips a minute. That's no small feat. So we've been using the kind of picker arrangement that you can see in the middle. We've got brick grading based on size, based on color, computer vision, combined with the robots. So quite a challenging environment. But you know, this is the kind of stuff we need to really advance construction manufacturing now, and in particular modular housing. So now I want to go, I'll just have a quick drink. Now I want to go on a bit more of a left field tour on a Horizon 2020 project we recently finished. And I've got two quite large use cases that I'll talk about. So Optimized received funding from Horizon 2020, competitively bid 119 projects, 8 were awarded. Really thinking about Industry 4.0 type technologies, how we could apply that to manufacturing, and to improve productivity and performance in manufacturing. At the time when we spec'd up the bid, it was around 3 key principles, which still hold true: measure, simulate, and then optimize. So what do I mean by that? Measure, we wanted to integrate data that we already captured in the shop floor that wasn't used. We wanted to add IoT sensors. We wanted to bring in wearables for some of our staff. Simulate was then about creating a factory simulation model, but then feeding it with live data, and so that we could understand whether the model, based on the data we were providing it, held true for today's production. So were we running behind? Were we low on staff? Are there any machines running slower than we're expecting them to? And then the optimized side was, okay, when you do identify something's wrong, can you optimize your production for the day, either by moving people or changing what you plan to manufacture today, to actually deliver what really drives your KPIs on a given day. 3 demonstrators. I'd said at the beginning of this, it was all about manufacturing. Turned out not to be all about manufacturing. So we had 2 manufacturing cases, one in Laing, one in a Spanish precision manufacturing business. And then the other one was the maintenance, repair and overhaul of the trains on the West Coast Main Line in the UK. So the kind of MRO scheduling. And I'll talk about those in a bit more detail. So Alstom Transport maintain all the rolling stock for the West Coast Main Line for Virgin. They have a number of depots. In fact, I'll just skip on to the next slide. So they've got 5 depots, 56 trains. Every 20,000 miles, the trains need to have a statutory service. 20,000 miles is about 23 days. If you nicely route balance the trains on the network. So at the moment, every day, the 56 trains are assigned to a particular route. So that'll be London, so that's Euston to Birmingham to Liverpool, then back to Macclesfield to Manchester. So that has to be done every day at the moment for 56 trains. It takes a human 3 hours to do that activity. As you can see from this diagram, it's quite a complex task of routes, and you can start to understand why they only ever schedule 1 day ahead, and it takes them 3 hours. Now, bearing in mind I've said that the 20,000 miles is 23 days, then the perfect world for them would be to actually forward plan every single train for 23 days. Because what really happens at the moment is, because they can't guarantee that a given train will get to a particular destination on time, because there may be problems on the line, or they may have to swap some trains out because they're suddenly expecting higher capacity on a particular route, then they have to over-maintain. And they over-maintain at around about 18,000 miles, which basically means every time they run a maintenance, every 9 times they run a maintenance activity for their statutory maintenance, they've done an extra sequence of maintenance, which clearly is a commercial loss to them. And if they could reduce that over maintenance, so thereby squeezing from 18,000 up to 19.5, 19 and beyond, then clearly that's a big commercial benefit. So to optimize that, we recognized as a project that we needed to create a digital twin of the rail network. And this is an interesting story, that we had a lot of pushback from Alstom, the client, about the need to create a digital twin and why would we want it? It's got no benefit. Nobody's ever done it before, and we had to really convince them to believe in us. The second we generated the digital twin, which I'll show you in a second, all of a sudden the light bulb went off with the client. They suddenly realized they could play what if scenarios, change the number of trains, change the number of depots, move the location of the depots, and it would help give them a KPI assessment of performance. So that's been a massive light bulb moment in Alstom. And this is the digital twin tool and a video of it running. So you can see, it's obviously time sped up. The train's moving along the routes of the network. You can then zoom in on a particular train to understand what it's doing. You can understand its mileage logbook, so you can check how its mileage growth is happening. So again, they're now fast forwarding multiple days, and you can see the plan for that train and in its operational state and maintenance state. So they could have certainty that the digital twin was operating as per the rules they'd given us, and was forward calculating for the 23 days. Now, to try and optimize that search space of 56 trains, it's quite a complex search space computationally. It's 10 to the power 74, and that takes human 3 hours. If you want to do 23 days, it's 10 to the 74 to 23. That's an enormous search space. But really, that's just a computation search space. And what we've done is we've put a number of constraints, which in essence were the intelligence we gained from the operators. So we modeled the human expertise. And then we've just got a simple hybrid AI optimization approach to really look for suitable candidate optimization. And to give you some results on that, we managed to reduce over maintenance by 60%. So that's taking the 18,000 up towards the 20,000. 60% reduction in over maintenance is enormous commercial benefit for Alstom. Planning time reduced, it says 83%. Well, in actual fact, we took 3 hours to 19 seconds, which is 99.7%. But we've only claimed 83% because they have to spend 29 minutes checking the output of the tool because it's not production ready. So we need to go through a validation and productionization phase. And then, in terms of benefit to us and to Virgin, they've managed to significantly reduce the train swaps. So, they're trying to get a particular train to a particular depot that evening, and they reduce that because they're able to forward plan a lot better. And the chart on the bottom right kind of shows the computation time versus number of days of simulation. So the chart goes up towards 16 at the end, and that's only 1,000 seconds. So whilst it's going exponential at that point, this is just a matter of throwing compute resources. And when you're trying to pre-plan 23 days, you don't need an answer 5 seconds later. It's quite happy to leave it running for a couple of hours and plan the next month. If I move on to the Laing O'Rourke case, I'll just run through a video so you can see our factory and the context of the project. That should say during peak national grid hours. So one of the things we also looked at was could we evaluate if we were in a demand side response and getting paid to respond to the national grid and go off network, could we replan our factory for shutting down our high energy consuming machines for a given period, and what would that do to our production KPIs, and could we sustain it, and would it be financially beneficial? Well, the answer is yes, it would be financially beneficial, but given that we're quite, in reality, quite a low consuming, power consuming factory, it's not as at the scale I would have one day dreamed of. We did the cost model, and it's a 13k benefit. However, we're under a megawatt, and normally we wouldn't be part of a demand side energy scheme. But of course, if you were running a big factory, then with multiple megawatts of power capacity, then there is we believe there's significant opportunity to be had from using a scheme like this and getting benefit from demand side signal to the grid. So remember those three key principles: measure, simulate, optimize. So this slide's talking about the simulation model we created. So we took a standard discrete event simulation tool, created a model of the factory and all the sequencing of the multiple production lines that we've got, and then used it to calculate the production KPIs. And then we used an optimization methodology that interacts with this whole middleware. So we receive data from the shop floor. That data interacts with this digital twin, and then we use an optimization algorithm to reschedule the staff and the production order sequencing to deliver the factory, and then recalculate the KPIs. It's quite a flexible architecture that we've created, so it can be either on-prem, up in the cloud in Azure, or actually a mixed cloud on-prem scheme like this. One of the things we recognized was it's fine generating lots of IoT data, but how do you actually guarantee that you get it to the cloud if you've got a slow connection or a connection that you're not the priority on? So we recognized we needed to create a kind of data collector instantiation of the middleware that would just buffer the data, and then as and when the internet connection was available, it would upload that to the live environment, to the live modeling and sequencing environment. Luckily, we're not generating gigabytes of data per second, but in that kind of scenario, this is absolutely vital. We could have probably bypassed this at risk, but we wanted to create a flexible architecture that supported this eventuality, because the plan is to install this this system on our next advanced manufacturing facility that we're planning to build. The importance of dashboards and diagrams can't be underestimated, and one of the things we found particularly useful is, irrespective of the digital twin or the optimization, it's just been surfacing data and making some of that data visually available. So you can see the spider diagram in the middle. It's actually crane path. So we added some sensors to the crane hooks and put in a tracking system. And we'd always had this anecdotal evidence that some of our cranes were being bottlenecks in production. So what we did was we added some sensors and then actually generated a lot of useful data for our team to understand where the cranes were spending the majority of their time, and help them to justify business cases for further investment. Another example is the bottom left. You kind of see that's the layout of the factory and the pallets. You can see there's one of the pallets towards the center of the image highlighted in red. The aim of this was really to help our production supervisors with an indication that, in essence, that working area is short of people, and you need to go and focus that. So not just about having the tool do everything, also just surfacing data and dashboards so that our production team could go do their own job more efficiently. classical Gantt chart and sequencing of production sequences on the right. And then towards the top is our KPI assessment. And then what happens if you run an optimization? Do your KPIs improve or are they reduced? And what are the key parameters that you actually want to optimize on a given day or a given week? As well as then towards the middle on the right is yard utilization, because our yard and yard capacity has been a key problem for us, and just understanding that on a forward plan basis based on the digital twin simulation of what's happening over the next week in terms of production orders enables us not to end up in a situation where we stop production. So to give you the kind of overview on the numbers, 2% surface level increase. So that's really just delivery on time orders. So not a major gain. The interesting one for us has really been the staff cost reduced. Now, this isn't about reducing people, and it hasn't reduced people. What it's done actually is better allow us to understand how we could better schedule our shifts and our shift patterns and the number of staff on those shift patterns to actually deliver a certain KPI productivity through a given week. And because of the type of contracts we've got, this means what we're actually doing is we're reducing overtime, significant overtime. You know, the type of overtime where people have already done a 5-day long week and then we suddenly ask them to work the weekend because we're behind and we're needing to get product out to the door. So we're seeing some real positive benefits from this type of scheme in reducing the stress and demands on our staff. It's nice to have a planning time reduction in 60%. It makes the planners' job easier and it allows them to focus on real value add rather than just the simplistic task of planning. But then if you do get a disruption where 3 people don't turn up today or a machine breaks down, the capability of the digital twin and the optimization algorithm to present a number of solutions to the operators is a real benefit and a real stress reducer. And then the diagram at the bottom is just really demonstrating that we were able to reschedule the factory production when we had a demand side response, and you can see the level of where we had to cap energy to. So we simulated this, and then how we could carry on with some production, and then how we would reschedule the rest of production. And that was it, to be honest. Daniel?
Thank you very much, Graham. Great presentation. I know we had a few people on the call message me to say that they had to shoot off a little bit early, but for those of you guys that are still on the webinar, do we have any direct questions for Graham at this stage while we have him here live on the session? We'll pause for a moment. Sometimes there might be a little bit of a lag. Okay, not a direct question, but impressive use of technology, and thank you very much for the presentation.
My pleasure. Always happy to engage with people. That's the great benefit of this, and you, Daniel.
Yeah, I mean, as I mentioned to you at the beginning of the session, Graham, the purpose of these virtual workshops, it's great when we have people live on the sessions, but this will be recorded and we will edit it up and make it available to the companies that are members of our network. So, these guys will be able to share with their teams. If anyone has any direct questions for me, and maybe I can make an introduction to you at some stage.
Yep.
Or, I'll send you an email. I'm sure you'll be happy to follow up when you have the time. But yeah, it seems at the moment there's no real direct questions apart from people saying thank you for the talk. So we'll wrap it up because I know time is a little bit tight for you. Thanks again. It was great to meet you at the workshop a few months back, and really appreciate the time you've taken to do this today. And I'll provide some feedback for you over the next couple of weeks.
That's great.
Thank you very much for your time. Cheers. Take care. Bye-bye.
Thanks. Bye.